presentation, the Buck O'Neill Bridge Environmental Assessment and Access Justification Report by Joshua Scott of Missouri DOT. And behind that question pane, there we go. Great, Joshua, welcome. And as mentioned, Joshua works for MoDOT in the Kansas City office in the design department, and has been a VSIM user since version 3.7. So excellent. We should do a little.
Thank you very much.
Yeah, we should do a trivia question later on. So perfect. All right, I'll hand it over to you. Thank you.
All right, thank you very much. As you mentioned, this is a presentation about the VSIM analysis we did for the Buck O'Neill Bridge environmental assessment. This presentation is tailored towards a different kind of safety analysis that we completed using VSIM. And to be honest with everybody, I hope I never go through this process again because it was extremely painful. But I do believe that there is a future in using VSIM for safety analysis. And so I'm hoping that maybe by presenting this today, that somebody will be inspired to maybe take this on and take it to something that is usable for pretty much any project. I found inspiration for this from a PTV webinar on SSAM. And so I'm hoping that that by showing this, somebody else will be able to move the ball forward on using VSIM for safety. A quick background on the project is on the top part of the screen is the Buck O'Neill Bridge, which takes US 169 over the Missouri River. US 169 north of the river is a freeway. The bridge needs to be replaced. But one of the operational challenges we have is we've got US 169, which is a freeway, comes down to a signal before it interacts with Interstate 70 and Interstate 35. The proposed project that came out of the environmental assessment is to provide direct flyover ramps from US 169 to I-35. So basically half the traffic can now bypass the signals there at 5th and 6th Street. I have to point out this is a design build project, which and so we don't actually know what the final configuration is going to be, but this presentation will be based on the this configuration that was the preferred alternative out of the environmental assessment. Burns McDonald was our consultant for the study, and they developed a VSIM model of the entire downtown freeway loop, which circles our downtown area. This project is in the northwest corner of the downtown loop. And I guess it's worth mentioning that this model was developed in version 8 of VSIM. I know there's that's several versions behind, but when we tried to bring it forward to a newer version, the model got out of calibration, and we decided to leave everything in version 8. So as you mentioned, I've been using VSIM since version 3.7, so I have a lot of confidence in VSIM for giving us operational results, level service, traffic performance. But when it came to safety, the state of the safety practice is not nearly as developed as operational using quantitative tools. The standard these days is the Highway Safety Manual, HSM, and for a project of this type, IHSDM is a common tool to apply the HSM. However, working with the safety team on this project, we really had reservations about using HSM methodologies for this safety analysis, at least as the only source of data. As you can see in this snapshot, the Kansas City downtown loop area has ramp upon ramp upon ramp. So some of these ramps are so substandard that it's not just substandard to the next ramp, but it's substandard to the second and third ramp, even beyond that. And HSM, it only looks at the next ramp. And there's other weaknesses to an HSM style analysis that we are hesitant to use that as our sole tool. And so we decided to look towards VSIM. Is there any information from VSIM that can give us some safety data? Two things we looked at are things that we've done in the past. We've tracked the number of lane changes. The more lane changes that happen, the more possibilities there are of crashes. We also looked at quick deceleration, emergency braking. So obviously, if there's a lot of people slamming on the brakes, that's an indicator of more possibilities of crashes. But as I mentioned last year, I watched a PTV webinar on SSAM. And so that really kind of piqued my interest. Is there some opportunities to use SSAM to evaluate freeway operations? We did use SSAM for arterials for the arterial parts of this project. But after an exhaustive 15-minute web search, I did not find anything that gave really any indication of how to use SSAM on freeways. And so I kind of said about, okay, so how could we use it? Is it even applicable? And so what I did is I took our calibrated model and I stripped out all of the network and I just put in real simple geometries, basic merge, basic weave, and that sort of thing. And then just started running tests using exporting the trajectory files out of VISM and importing that into SSAM. That's a whole other topic if you want to learn more about that. But as I started getting results, I started getting kind of concerned. And you see the graph at the bottom where it was telling you that a short merge had less conflicts than just a basic freeway section, straight freeway, and less crashes than a standard merge. And so I couldn't really understand what was going on in that interaction between VISM and SSAM. So I kind of dug into the results of the SSAM to see, okay, so what is it calling a conflict, and visually does that make sense to me? And I guess as I say this, I've not been trained in conflict analysis. I know about it, and so I've done the best that I can with what I know about it. So that's just where we're at. In the spreadsheet, what you can see is those that are highlighted red are examples where SSAM said there's a conflict, and I was able to visually confirm, oh yeah, that is definitely a conflict. The ones that are completely in white, those are ones that SSAM said was a conflict, and as I watched it, I couldn't tell that there was any sort of conflict there. And then there's the ones that are kind of in green, I'll talk about on the next slide. And I also want to point out that this method that I used to confirm visually what the SSAM was saying was a conflict, I also used in this alternative method that I'll be talking about here in a little bit. As I mentioned, if it's important to check that what the procedure says is a conflict is actually a conflict. It's also important to see, is the procedure missing conflicts? And so I use two different methods for looking at the VISTA model to see, is there a conflict that, in this case, SSAM missed? One was to use a lane change record out of VISM. And so basically I watched every lane change to determine if there was a conflict. And so in this example, you can see the top two that have a little picture with it, SSAM had identified as a conflict, but that bottom one visually it appeared to be a conflict, but it was not flagged by SSAM. So I counted that as a miss. The other approach I used was I looked at emergency braking. For this, I used the vehicle record file, and I filtered out all of the accelerations that were greater than 10 feet per second squared, and I watched all those vehicles as they were in that emergency braking state. And I did the same thing where I visually observed, did that appear to result in the conflict or not? Going through all this, I never got to a point where the reported output from SSAM and my visual comparisons, I never got closer than 40% correlation between the two. And so I was kind of pondering, okay, so well, how can I make something usable out of this? I kind of had it's an epiphany that in VISM, the vehicles recognize conflicts and they react. And so the question is, can we take that information from the vehicles to determine when they believe they're in conflict? And to do that, I use the vehicle record file. The important factors that I used out of the vehicle record file is the acceleration, the driving state, especially the changing lane feature of that, the following distance, the interactive state, and I just lost my presentation. There we go. The interactive target number, which is it tells you what vehicle that is following if they're in a following state, and then the safety distance. I guess it's important to note that you can change what fields are reported in the vehicle record file. Those are changeable within VISM. So from these values, I derived two separate values. One, which I called conflict time, which is basically the time from when a vehicle starts to change a lane to when we are evaluating if there's a conflict with the vehicle following it. So basically, if a vehicle changes lanes and 2 seconds later a vehicle enters a following state, then during that time step, the conflict time would be 2. And then the following time step, the conflict time would be 2.1, 2.2, so on. And so it's just a measure of how long after the lane change began that you're evaluating if there's a conflict. The other one's a pretty simple mathematical formula, follow ratio, which is basically the following distance divided by the safety distance. So what percentage of the safety distance is that following vehicle at? So here's the evaluation criteria I finally came up with. And I warn you, don't write these down number by number, because this took a lot of effort to tune just for our specific calibrated model. I doubt it would be applicable to anybody else's calibrated model, but I do want to present the basic concepts. And like I said, maybe somebody can find a better way to evaluate conflicts in VISM than I was able to find. I guess to start with, it all begins with a lane change. And so this method does not evaluate if a vehicle comes flying up into a back of a queue and runs into a vehicle that's in front of it. This is all based on if a vehicle makes a lane change, is there a corresponding conflict that's associated with it. So kind of going through these checks that each lane change was evaluated against. The first one is basically, did they cut somebody off? Creating a potential conflict there. The next two are similar in that if they change lanes, did the person behind them have to slam on the brakes? And there's just two different criteria to check for that. The fourth one is I've got to reread it again. If the vehicle, when the vehicle changes a lane, if the vehicle following it has to change lanes to avoid a conflict. That's what that fourth one is. The fifth one is another one that's basically did they cut somebody off? And then the last bullet is the vehicle that's changing lanes, did they basically cut themselves off? Did they have to accept a gap to the vehicle in front of them that's smaller than they should? I guess the other thing that's worth pointing out is that the vehicle record files, we tested all of these conditions using an Excel macro. That's just the tool that I had available to me, and it's what I was comfortable with using. And so in testing, the simple geometries to see if I can get good correlation between those criteria and the visual inspection of the model. Here's kind of where I got a little, I guess, got off the tracks a little bit, and I kind of lost focus on what is the purpose of this. Because at the end of the day, what these numbers aren't significant by themselves. We'll never be able to correlate a number of potential conflicts to actual crashes. What's important is the relationship between alternatives. Does this one have more conflicts than this other alternative? But as I was going through this process, I was really focused on, could I correlate what the process, the criteria calls a conflict, with what visually appears to be a conflict? I was hoping to get about 75% correlation. But as you can see from these results, I was able to get 62% for what I calibrated to, and then a different scenario, I was able to get 55%. But I guess what I'm kind of embarrassed to say is that as I was creating this presentation, I realized I never went back and tested all those scenarios that I had tested in SSAM to see if relationally between these different types of scenarios that the conflicts make sense. Good, bad, or different. That's how we wound up. So with my calibrated criteria, I did test it against the two options, the no build and the central build central version that I showed you earlier in the presentation. Here was the other painful part of this. As you saw, the VISTA model was very large, and we were only evaluating probably about 10% of that network. As of version 8, I could not find a way to filter the output of the vehicle record file for just the links I was interested in. And so the vehicle record files got to be quite large. And so between the SSAM evaluation on the arterials and the special freeway evaluation, I estimate I generated about 10 terabytes of data. And I was running 4 desktop computers nearly 24/7 for almost 3 weeks to generate these results. I guess at the end of the day, what's ironic is that the percentage difference between our no build and build central from this alternative freeway process is almost identical to the results that came out of IHSDM. And so with that, I am done with my presentation.